The following content is created by DrAvitech. Your support and donation will help me continue to offer high-quality educational resources for free. To make a donation, send an email to 6drcyril@gmail.com or comment donations below.
Welcome, ladies and gentlemen. I'm Dr. Arbitrary. Now let's talk about when the period is not 2 pi. Throughout the course of this study, all of the equations I've been solving before making this video, all of the equations, their periods were all 2 pi. And this is because Fourier series is the representation of functions in terms of sines and cosines. And we know that these two functions are periodic with 2 pi. So we've been using it for a very long time. However, some functions might not be periodic with 2 pi. They might not be. So if they are not, there has to be some formulas for them. Now, these are the formulas that we've been using. Whenever the period is 2 pi, these has been the formulas that we've been using throughout the course of this study. But there are functions where the period is not 2 pi. We then say that these functions have arbitrary period when the period is not 2 pi. So it's some other number. The period could be 1, period could be 2, it could be 3, it could be something else. So how do we then get our formula? Would it still be the same with this? Of course, no, it won't be the same. Now, if you rewind back to when I made a video about derivation of Fourier series coefficient, you remember that I said there's a much more general formula for Fourier series. There's a much more general formula. And there are varieties of it, please. There are varieties of it. So the one you might see in your textbook might involve omega. So there's an angular frequency or natural frequency. I'm not using that one. So the one I use would have L. I prefer the one that has L. So here's the one I'm talking about. So f of x is equal a naught over 2 plus the sum from n equal to 1 to infinity of a sub n cos n pi x over L plus the sum from n equal to 1 to infinity of b sub n sine n pi x over L. So this is arbitrary period. So the period is not 2 pi. So I prefer using this one that has over L. I prefer it. Yeah, I prefer it than any other one. I think people prefer using the one that has n omega x. I don't really like that one. But it's still the same, basically. It's still the same. So if you're using this is actually a much more general formula. If you're using this, your a naught will become 1 over L integral from minus L to L of f of x dx. Now again, please take note that formulas might look different, but in Fourier series, they all make up to be the same thing. So you might go to your textbook and the formula you'll be seeing will be 2 over t minus t over 2 to t over 2. It's still the same thing. It's still the same thing. I would explain as we proceed. Now a sub n is 1 over L integral from minus L to L of f of s cos n pi x over L dx. Then b sub n is 1 over L integral from minus L to L of f of x sine n pi x over L dx. So this is the formula. Now what does L mean, or what is L? L, let me kind of write it here. L is half the period. L is half the period. So this means that L is t over 2. That's the meaning. So L is t over 2. That's why I said if you notice in some textbook, they might put 2 over t here, because when you take the inverse of t over 2, you will get 2 over t. So some textbook will be having 2 over t integral from minus t over 2, because L is t over 2, and then you have t over 2. But I don't really like doing that. I'll first of all take half of my period first. I'll first take half of my period, and I know that that's my L. So I love calling L half the period. So I prefer using this formula. It's still the same. It's still the same. So L is half the period. Do you know that these formulas here, they're actually the same with this? Now let us say this is a much more general formula, remember. So let's say this L is, where is it? Let us say we want to deal with 2 pi. So we see how this would go to this. Now let's say the period is 2 pi. That means L will then become 2 pi over 2. So 2 we cancel 2. So that means L is what? Pi. Now let's come in. This will now become 1 over pi, you see, 1 over pi, integral from minus pi to pi, because our L is now pi. So this is a much more general formula. Then when you come here, if your L is pi, pi we cancel out pi. So you now have just cos nx remaining. So you see that that's just what it's going to be. So this is a much more general approach. It's still the same thing. It is still the same thing. Now what if the function that is an arbitrary period is having to be an even function, or it becomes an even function? So when it becomes an even function, our a naught will be 2 over L, integral from minus L to L of f of x dx. Oh, sorry. Since it's even, this will be half the range. Then a sub n is 2 over L, integral from 0 to L, f of s cos n pi x over L dx. So this is when it's an even function. Then when it's an odd function, our b sub n is going to become 2 over L, integral from 0 to L, f of x sine n pi x over L dx. Now, as you can see, I just prefer using this one. So most persons, like I said, this is a much more general formula. This would even work if the period is 2 pi. So all you have to do is to always say that L is half the period you are given. So I prefer using this one here. Now remember that these formulas here are still the same formulas if you were told to find half range. So if you're asked to find half range, this even guy actually means your cosine series. Then this odd guy would mean your sine series. So it's just still the same. So there's no much difference. This is just the difference between them. So with this, you can now solve problems when the period is no longer 2 pi, because that's what we're going to start looking at in the next few videos. So thanks for watching this. Let us move on and let us start solving problems that involves equations without the period being 2 pi. Thanks for watching.